Okay, so we're going to work through two sections, 1.3 and 1.5, solving equations, and then we're going to solve some inequalities, because inequalities are pretty much equations as far as how you solve them, same steps, with a couple of things we're going to do with the solutions. So we're going to have some properties that we're going to also apply to the equations as we're solving them, and I'm going to walk through you with some of those, and then some vocabulary that we're going to have will be solution and equation. All right, so one of those properties that we're going to talk about is reflexive. So you're going to see that what you can state about an equation is x plus 12 equals x plus 12. That's the example. So exactly the same thing is equal to exactly the same thing. That's a reflexive property. Kind of like your reflection in the mirror. You see yourself, that is yourself. So reflecting one value equal to itself, that's reflexive. So you can do that in an equation. Symmetric, it kind of looks like reflexive because you have the same thing stated within a mathematical statement. However, it's not just one single equation. You've got an if-then statement. And what do we have here? We've got 5 first, and then 2x plus 1 in our example. And then what happens here? Well, it is reversed. And that is the symmetric property. What it means is that your equation is the same forwards, and if I flip it backwards, you have the exact same equation. And we use this property when we want to turn it around. Most often people like this variable right here to be on the left side, just because we've been most comfortable with it being on the left. So lots of people use the symmetric property when we want to flip it around as a variable on the left side. And that's how it's useful. The transitive property. This is equating three values together because they have one in common. So eventually I can say 3x minus 3 is equal to 2x plus 2. Why can I say that? Because 3x minus 3 equals 12. 12 is also equal to 2x plus 2. And since I have 12 in common, equal to these other two quantities, then these two have to be equal because they are linked by 12. And that is the transitive property. If A equals B and B equals C, well then A and C have to be equal because B links them together. That's your transitive property. So it's a linking property. Okay, so remember, these are just ideas that help us solve equations. We're not going to sit and identify properties. Oh, look, that's a transitive property. Oh, look, that's a symmetric property. We're going to use them in equations. I'm going to call your attention to them and say, what did you just use? And kind of keep that uppermost in your thoughts. All right, so let's solve this equation, kind of refresh your memory. I want to get y by itself. So the first thing I need to do is I've got to move this 8. How am I going to move this 8? Opposite operations always come to mind. Right now it's being subtracted from the 6y, so I'm going to add the 8. I'm going to have negative 6y equal to 16 plus 8. So I'm going to get 24. Now I need to get y completely by itself. So I need to do the opposite of multiplying by the negative 6. So I need to do this opposite operation of multiplying by negative 6. So I've got to divide by negative 6. So y is going to be 24 divided by negative 6, negative 4. I have another property that's going to let me know that this value, in fact, is actually true. And that is the substitution property. That's how you check your solutions. So checking your solutions is using the substitution property. This equation, 6y, negative 6y minus 8 equals 16. So here's my negative 6. Here's my y. Minus 8 equals 16. So y, my arrow is showing you where I have substituted in the negative 4. So negative 6 times negative 4, that gives me a positive 24. minus the 8 equals 16. Negative 24 minus 8 gives me 16. So 16 equals 16. That is a true statement. That's an example of that reflexive property. Reflexive property tells you, hey, you have a true statement. That's the use of the reflexive property. So that negative 4 value that we got right here was true because of our check step. Reflexive property showed us that that was right. Okay, so here's a little bit longer equation that has a little more involved. Where should I begin? Probably at the distribute property that I've got. So I need to distribute 5 inside to that 6 minus 4x. I'm going to get 30 minus 20x. And then we got x over here. That's 21. What we probably need to do at some point, gather our like terms. Our like terms are the x's and the constants, the number terms. So most people like x's on the left, so let's move that x term over. So if I want to move that x term over to the left side, how am I going to do that? Well, it's a positive x right here. So if I want to cancel that out, adding it's not going to help me because I would have x plus x. X plus x would be 2x. That doesn't help me. I need to cancel it out, so I need to subtract it. So subtracting x, cancel that term. I'm left with 30 minus 21x equal to, all I have over here is 21. I need to gather my constants, so I need to move them to the other side. I don't want to have all the terms over here. That does not help me at all. I need variable terms on one side, constant terms on the other side, from each other on the other side of the equal sign. So I need to cancel out this 30. If I add these two together, I'm going to get 60. It's not going to help me. So I need to cancel out by subtracting. I'm going to be left with negative 21x 21 minus that negative 30. That's going to leave me with negative 9. So I need to get rid of this multiplying by negative 21 right here. So opposite of multiplying by negative 21, I need to divide by negative 21. So if we pull up the calculator page and do negative 9 divided by negative 21, well, we have a negative divided by negative. So that's going to give us a positive answer. Let's look at this. So we have, you want to use that template, use your, we enter there. Don't want that. All right, so 9 over 21. Let me go ahead and hit Control and Enter. And we get 0.428571. Let's do 2 decimal places, so 0.43. So I have x equals 0.43. That would be my decimal answer. Inequalities. Same as equations as far as all of our steps. The only thing that we have is in place of our equal signs, we are going to have these symbols. Greater than, less than. Greater than, equal to, less than, equal to. The difference that we get in those symbols is if I have greater than, less than, I will have an open circle on my graph. If I have greater than, equal to, less than, equal to, I will have a closed circle on my graph. So I will be graphing these solutions on a number line. So the only other rule that you have to remember is when we multiply or divide by a negative number, we're going to flip that inequality symbol. So these symbols will switch over. They will flip over. So a greater than symbol will flip over to a less than symbol if I divide by a negative or multiply by a negative. So let's do a problem. All right, so this looks pretty much just like an equation. Oh, the only thing is that instead of an equal sign right here, I have a greater than sign. So I need to get W by itself. I need to move this 13. How am I going to move that 13? Well, right now I'm subtracting it, so I need to add it so I can cancel it out. I'm left with negative 4w. I still have greater than, what is negative 21 plus 13. That is going to give me, I don't know, negative 21 plus 13. Let's check it. That is not what I wanted. Negative 21. No. I'm not typing this in right. 21 minus 13. Okay. Yeah, still not typing it in correctly? Okay. Right. So that's the end. Negative 21 plus 13. Okay. Now we have negative 8. Good descriptions. Negative 8. Okay. So I need to get rid of the multiply by negative 4. So I'm going to divide by negative 4. What was this other rule that I said we had to remember? We divide or multiply by a negative number, we flip the inequality symbol. So I'm going to flip this inequality symbol. This is now going to flip over. I'm going to have a less than symbol. I have W. I've canceled out those 4s. I have negative 8 divided by negative 4. I'm going to have a positive. That is 2. So here's all my solution. W less than 2, I'm going to have an open circle with 2. As long as my variable is on the left, as long as that variable is on the left, you can look at your inequality symbol, and that will point you the way that you are supposed to shade in your number line. You need to also think about the fact that it's saying W is less than the 2. So that is all the variables, all the values of your solutions are less than 2. So all your solutions are less than 2. Where are those? Less than 2. These are the numbers that are less than 2. That's what we'll shade in. All right, one more. A little more complicated problem. So we are needing to get this x by itself. We have a lot of stuff going on. First of all, and probably what makes you most uncomfortable is that 5. That 5 is being divided, so we need to do the opposite. So let's multiply by that 5. And multiply through. I'll cancel that out. We get negative 15x over here. We'll have negative 4x left over plus 22. We need to get x's all together. So let's move this x over there. So I have 4 x's. If this was negative, I need to cancel it out. Let's add 4x over here because the negative 4x and positive 4x together will cancel each other out. That leaves me with a negative 11x over on the left, less than or equal to 22. And that is fairly neat. So I need to get rid of this negative 11. So since it is multiplying by that x, I'm going to divide by a negative 11. So once again, I'm dividing by a negative. That means what's happening to this inequality? This less than or equal to is going to flip over and become a greater than or equal to. So I have x is greater than or equal to a negative 2. 20 times 11 goes into 22. So let's graph this solution. So because I have the or equal to, I have a closed circle at the negative 2. And my variable is on the left, so my inequality points me the way I need to go. But also think about it, so this x is greater than. So read this, x is greater than. So where are the x's greater than? They are greater than over here. So I will shade to the right because those numbers are greater than negative 2. And that gets you through solving equations and inequalities.